Hello, how are you? How are you all doing? In this video, we're going to see how we can simplify algebraic fractions. To make this very clear, I'm going to solve a total of 8 exercises. I'll start with simple exercises, and little by little, we'll make them more complicated, so that exercise number 8 will be very difficult. So I recommend that you go little by little so that this really becomes very clear to you. And look, before we start with the explanation, I think it's absolutely necessary to say something that might sound a little harsh. But look, it's the following. If you don't know how to factor, then don't stay to watch this video. Why do I tell you this? Because you're going to waste your time. And the thing is, for you to really learn how to simplify algebraic fractions properly, it's absolutely necessary that you know how to factor. If you don't know how to factor, I recommend that you go to the description of this video, because there I put a link to a complete playlist that I already made. The thing is, here, listen, my focus is not going to be on explaining how to factor, because I already explained that in previous videos. My focus is actually going to be on explaining what we need to do in order to simplify algebraic fractions. That's where we're going to focus. Okay, and well, before we start with the first exercise, it's necessary for you to know exactly what we have to do. I mean, if I want to simplify this algebraic fraction itself, what am I supposed to look for? Look, when you were in elementary school or in the first year of middle school, you probably remember seeing something like this. For example, when you were asked to simplify 6/4. Here, what we would say is, I can divide 6 by 2, and I can also divide 4 by 2. We would say, oh yes, you can, because they both have a half. And we would simply write half of 6, which is 3, and half of 4, which is 2, right? That's what we used to do. Another thing we could have done, which actually isn't that common, but I'm going to do it now, is the following. I can express 6 as 3 times 2, right? While I can express 4 as 2 times 2. Now, as you can see, 2 divided by 2 is 1, right? So, 2 divided by 2 is 1. So can I cancel them out? I put this number 2 in quotes with this number 2, and what's left for me? Only, just a 3 in the numerator and a 2 in the denominator. So this will be the simplified fraction, right? Well, in elementary school and in the first year of middle school, we could do something like this. Notice that what I'm really doing here is factoring 6. That is, I'm expressing it as a product of factors. And here I'm also factoring 4, meaning I'm expressing it as a product of factors. So, what do I have to do here? When they are algebraic fractions? Well, the same thing. What I have to do is factor the numerator and factor the denominator, so that I can then cancel something. I'm not really canceling it, right? The division will give 1, so let's do it step by step. First then, it's absolutely necessary for us to remember how we can factor both the numerator and the denominator. Think about it. How can we factor the numerator? You'd agree with me that we can factor the numerator by common factor, right? All right then, let's factor the numerator. The common factor of 2x squared plus 3x is x. So let's write it down. We open parentheses and ask, what do I multiply x by? To get 2x squared, that would be 2x. We write the plus sign. Then what do I multiply x by to get 3x? That would be 3. I close the parenthesis and make a note here. If you feel like you're not understanding how I'm factoring this, then honestly, there's no point in staying in this video. Since it's assumed that for you to understand this, you first need to know how to factor, right? All right, we have our line here, so let's continue. Now that I've already factored the numerator, let's factor the denominator. In this case, notice that we can factor it using the difference of squares, right? This is a square and this is another square, so let's go ahead and factor them out. We calculate the square root of 4x squared and the square root of 9. The square root of 4x squared is 2x. So we'll have 2x, and we put a plus sign. Then, the square root of 9 is 3. We close the parenthesis, and remember that in factoring by difference of squares, we have to write a plus b times a minus b. So here, I need to multiply by 2x minus 3. All right, let me extend the line a little bit. Notice the following. See that here we have a factor that is repeated both on the top and the bottom. Therefore, if I do 2x plus 3 divided by 2x, 2x plus 3, yes, divided by 2x plus 3, look, this one over this one, then it's going to give me 1, right? This division gives 1, so I can cancel them out. From now on, I'll be saying that I'm going to cancel them, but we really already know that what we're doing is division. I mean, division that gives 1. So, am I going to cancel this one with this one? And I'm only going to have 10 left in the numerator. And in the denominator, I'm only going to have 2x minus 3. 2x minus 3. There you go. What I have here, x over 2x minus 3, is already the simplified algebraic fraction. That's it. I'm done. Okay, this is what we're going to be doing. So as you can see, it is absolutely necessary for us to know how to factor. I insist on this. If this step was difficult for you, I mean, the factoring itself, then there's no other way. There's no other option. Sorry, you have to go down to the video description. Let's see now. What happens with exercise number 2? Look, in this case, in number 1, we were able to factor on the top, and we were also able to factor on the bottom. But there are times when you can't factor either the top or the bottom. That is, either in the numerator or in the denominator. That's the case, for example, in exercise number 2 in the numerator. We can't factor it. Look, how would I factor 1 plus 2a? Well, you can't. In this case, I recommend the following. If you can't factor either one, do the following. You're just going to put a 1 just like that, a 1. Then you're going to open parentheses and write exactly what we have here. 1 plus 2a. Why do that? Because 1 plus 2a is the same as 1 times 1 plus 2a. I'm not doing anything wrong, right? It's useful for me to leave it that way. You'll see why soon. So, let's see. I draw the line and let's factor the denominator. Let's see. In this case, we can also factor by common factor, right? Notice that 3 is a common factor, and so is a squared, so let's put 3a squared as the common factor, open parentheses, and ask ourselves, by what? I multiply 3 a squared by 2a to get 6 a cubed, right? Then, what do I add? I multiply 3 a squared to get 3 a squared. Oh, well, by 1. As you can see, again, we have factors here that are common on the top and bottom. That is, here we have 1 plus 2a on the top, in the numerator, but we also have it on the bottom, just that it's flipped, so to speak. No, because it's really the same thing, right? 1 plus 2a, isn't it true that it's the same as 2a plus 1? Therefore, if I divide this by this, the division equals 1, so we can cancel them out in such a way that I can remove this one with this one. And I'm only left with a 1 in the numerator, so we write it down. And in the denominator, I'm only left with 3 squared, so let's write that down as well. Now we have our simplified fraction. Let me see. Excuse me, I want to point out something here that is extremely important. Notice that if we hadn't put this 1 on top when we canceled the 1 plus 2a with the 2a plus 1 on the bottom, what would have happened? Well, we wouldn't have anything on top. So since we wouldn't have anything, a lot of people think that on top, it's 1, 0. But actually, there's not a 0 on top. Why not? Because if it were 0, 0 times 1 plus 2a would equal 0. But there was a 1 on top, multiplying by 1 plus 2a. So, that's why it's important that when you see you can't factor either the numerator or the denominator properly, remember that what you have to do is put a 1. All right, that's really important. Make sure you do it correctly. Now, let's move on to exercise number 3. In this case, we have x squared minus 3x plus 2 over x squared plus x minus 6. As you can see, we'll factor in the form x squared plus bx plus c, just like trinomials. And to be able to do this, we had to look for two numbers such that when multiplied, they give c, and when added, they give b, right? That's what we had to do. Let's go step by step. So, for this case, I'm going to have to open a pair of parentheses. So open, and close. Now let's factor the numerator. we write the square root of this, that is, the square root of x squared, which in this case is 10. And then we're going to look for two numbers such that when multiplied, they give 2, and when added, they give -3. What would those numbers be? -2 and -1, right? So, those numbers, -2 and -1, are the numbers such that if I multiply them, well, if they give me 2, -2 times -1, that gives me +2, but if I add them, I get -3, right? Look, -2 and -1 add to -3, so I've already factored it. Now let's check the denominator again. Let's go ahead and open and close parentheses. We put the square root of this one, which would be 10, and also 10 over here. We need two numbers that multiply to -6 and add to 1. It might not seem obvious, but there's a 1 here, right? Because it would be in 10 so, think about which numbers multiply to -6 and add to 1. That would be 3 and -2, right? So let's write it down. It would be 3 and -2. Let's see. Let's check. 3 times -2 is -6, and 3 minus 2 is 1. So it's correct now. Those numbers multiply to -6 and add to 1. All right, let's try again. Let's see if anything cancels. If it's a division by 1 like 10 minus 2 over 10 minus 2, then yes, it cancels. I want you to notice that they don't necessarily have to be aligned. Well, here they're not really aligned, here they're not either, and here they're obviously not aligned. But it doesn't matter. The point is, you have a top and bottom number, or, well, in this case, an algebraic expression on top and bottom that's repeated. So, let's go ahead and cancel these two, okay? These are the factors that we have repeated on the top and bottom. All right. So what's left for me in the numerator? Well, just x minus 1. And what's left in the denominator? Well, just x plus 3. So, let's go ahead and write it down right now. We're done. We've already simplified this algebraic expression. Look, before erasing these exercises and moving on to others that are a little more difficult, it's important for you to notice something. I want you to see, look at the degree of this expression. The algebraic expression was of the second degree, right? And look, this one was also of the second degree. Now I want you to see that here it ended up being first degree and first degree as well. So, how can you tell when we simplify and lower the degree? Notice, this one was first degree and this one was third degree. The degrees also went down here, and it's the same here. Wasn't it second degree before? But now it's only first degree since the degrees dropped? So, when you simplify an algebraic fraction, what you'll actually get is also an algebraic fraction, but with a lower degree. That's really what you're aiming for. Okay. Now, another important thing you should ask yourselves is, what happens if, when factoring, nothing gets cancelled out? I mean, what would happen if, for example, here it was, I don't know, x plus 5 times x minus 1, and we had the same thing below? In that case, we wouldn't cancel anything. So what could we do? We really couldn't do anything. Because in order for us to simplify algebraic fractions, well, they have to be simplifiable. So if you suddenly find an algebraic fraction that can't be simplified, well, it could be for different reasons. The main reason could be because it wasn't set up correctly. And the second could be because it was possibly a trick question. It was an exercise that couldn't be done because it couldn't be simplified. So you need to be sharp about that. Many times it also happens that when you try to simplify a fraction with the first factorization, you can't simplify it. Meaning you can't cancel anything, and you have to factor it again. We're going to do that, for example, in the last exercises, and you'll see what I mean. All right, now let's erase this and continue. Exercises 4 to 6 already look much more complex, right? But essentially, we're going to keep doing exactly the same thing. Again, we're going to have to see how we can factor the numerator and the denominator. Let's see. The numerator, if you notice, is a perfect square trinomial, right? So, since it's a perfect square trinomial, because here we have an exact square root, and this one also has an exact square root, and if we calculate the square roots of these two terms, I would get m and 3. And if we multiply them, 3 times m gives me 3m, and times 2 gives me 6m, which is the term in the middle. I insist. It's important that you already know how to factor, right? Well, then this is a perfect square trinomial, so we can factor it as m plus 3 squared, right? So I'll end up with m plus 3 squared. Let's write m plus 3 squared as m plus 3 times m plus 3 instead. Why do this? Well, since I already know... Hold on, let me get my ruler. Sorry to interrupt. I know I'll need to cancel something, right? Since I know I have to cancel something, that's also why I already know that, in the end, I have to express it as m plus 3 times m plus 3. Because if I write it as m plus 3 squared, it won't be as obvious. What do I have to cancel, okay? That's why I'm writing it this way. All right, now let's factor the denominator. In this case, we're going to have to factor by grouping, right? So, for this, we calculate. Or rather, we find the common factor between this term and this one. Their common factor is m, so we're going to write m. We open parentheses and I ask, by what? I multiply m so that I get m squared. So it would be by m. Plus, by what do I multiply m to get mn? That would be by n, then I'm going to put the plus sign, and we factor these two by the common factor. In this case, the common factor is 3. So we put 3. We open parentheses and I ask, what do I multiply 3 by to get 3m? Well, it would be by m. By what do I multiply 3 to get 3n? Well, it would be by n. All right, let me extend this a little here, and we'll continue. I want you to notice that I still haven't finished factoring here, right? Because when I'm done is when I see that we already have everything as a single product of factors. But in this case, we have a sum here, so it's not factored yet. So we have to continue. I want you to notice that m plus n is a common factor, right? Since it appears in this term and in this term. Therefore, I'm going to keep writing the numerator. Excuse me, I'm going to get a little crowded here. This is just because of space. So I'm going to write the numerator again, which was m plus 3 squared, that is, m plus 3 times m plus 3. And in the denominator, now I'm going to write it factored, okay? So, let me put this line again, and we'll continue from there. Nothing was written. I think I was drawing with the ruler. All right, in this case, we agreed that m plus n is the common factor. So we're going to write m plus n, okay? I open parentheses and say, what do I multiply m plus n by to get this whole term? Oh, well, by m plus. What do I multiply m plus n by to get this whole term? Oh, well, by 3. There you go, you see. And in this case, as you can see, we already have that m plus n. Sorry, that m plus 3 divided by m plus 3 gives me 1. So does that mean we can cancel these out? All right. So what do I have left? Only, well, just m plus 3 over m plus n. Let me write it up here. Okay, because I'm going to erase this part since it's in my way. For exercise 5, we already have the solution. M plus 3 over m plus n. Let me fix it. If you can see it, yes, you can see it. So let's box this, and that's it. We have our solution. If you are copying it, I recommend that you include this little step I have here, right where it goes. Okay, I'm going to erase it for space reasons. But now you've seen exactly where this final result comes from. That's it. We're done. It got a bit complicated, right? Let's move on to the next one. In this case, I want you to see that once again, these are trinomials, but they have the form x squared plus bx plus c. That's the form they have, so you can look for them as trinomials of the form x squared plus bx plus c. And this one, well, it's the same. It has the form x squared plus bx plus c. Therefore, we're going to factor them, and a good factoring technique would be to use the crisscross or scissors method in this case. So, let me write the numerator here first, and then the denominator, so we can factor them independently. Okay, good. So let's see. I'm going to use black to factor them. Let me copy the numerator. I decided to copy them here. Well, I decided to copy it here because it's not that easy to factor these, okay? Let's see. To factor them using the crisscross or scissors method, we're going to do it a bit by trial and error. What we did was break down this term and this term as a product of factors. So, what gives me 6a squared? Well, one possible combination could be 3a times 2a, and you write them below. 3a times 2a. That gives me 6a squared. And also, what gives me minus 6a? Sorry, minus 6. What gives me minus 6? Well, it could be, for example, minus 3 times 2. So let me write it. Minus 3 times 2. That's minus 3 times 2. And that gives me minus 6. All right. What we did next was cross-multiply. So I cross-multiply and cross-multiply. I do the multiplications. 3a times 2 gives me 6a, and then 2a times minus 3a gives me minus 6a. Finally, what we did was operate here. Minus 6a plus 6a gives me 0. Well, if when I do these operations I get the term that's in the middle, does that mean yes? I factored it wrong. In this case, I want you to see that I didn't factor it correctly. Why? Because I got 0 and I should have gotten 5a. All right, so that's what we have to do. But since this is trial and error, as I was saying here, we can start thinking about what we need to do. If I put 3 here and 2 here, it'll work, right? Look, I'll do it so you can see. So I put the minus 2 over here and the 3 here. In the end, it's still correct. No, because minus 2 times 3 is minus 6, but that small adjustment fixes it for me. 3a times 3 equals 9a, and 2a times minus 2 equals minus 4a. Now I add minus 4a and 9a. Now I get 5a. So since I'm getting 5a now, does that mean I broke it down correctly this time, right? Well, it turns out that factoring consists of putting this one with this one in one parenthesis, and this one with this one in another parenthesis. And that's it. So come on, let's write it over here. The factoring. So, from the trinomial, it would be 3a minus 2, that is, this multiplied by 2a plus 3. 2a plus 3. Sorry if it seems crowded, but you understand, right? All right, it's already factored. Let me see if I can move a bit. No, there's not much space left. All right, it's fine. Let's erase this. And now let's factor the denominator using the same method. Okay, so let's do it. We'll copy it. It's already over there. So now, let's break down the 2a squared, which could be 2a times a. And let's break down the minus 15, which could be, for example, minus 5. Well, you know what? Let me put a 3 here. Let's see if I get a 3 in the first one, and a minus 5 here. I think that'll work, right? Let's do it. We multiply. This times this gives me this, and this times this gives me the one above. We're doing well. Multiply across. 2a times minus 5 is minus 10a, and a times 3 is 3a. Combine them. 3a minus 10a equals minus 7a. I got the first one right, so that's it. We already have the factorization. Remember, it's written like this. Therefore, let me draw the line. The factorization would be 2a plus 3. I write it multiplied by a minus 5. We put it there, and that's it. We have the factorization. Now we can erase this, because this was just to be able to factor. And now let's see if we can simplify, right? In theory, we should be able to, since the exercises are designed to be simplified. In this case, as you can see, we have 2a plus 3 here, and also 2a plus 3 here. So, do these cancel each other out? I'll just have 3a minus 2 on top and a minus 5 on the bottom. That's it. We're done. So the simplification of this algebraic fraction is done. In this case, as you can see, we can factor both the numerator and the denominator by grouping. So let's do it. I'm going to go a little faster with the factoring, because again, I assume you already know how to factor. All right, let's do it. Here we take the common factor of these two terms, which would be 2x, right? We write it down, open parentheses, and here I would have a, then I would have minus what? 2b, right? 2b. All right, look, I'm already factoring these two by common factor. Here we do the same. We factor these two by common factor. In this case, the common factor. Well, it's just the, and then I'm going to add and say, by what? So that I get 2 by, well, it would be by 2b, and then by what? So that I get, oh well, minus. Oh, it would be by minus a minus. Okay, I'm going to draw the line. And now we're going to factor the denominator the same way, by grouping. We look for the common factor of these two terms, which in this case is a. So we put it, open parentheses, and in this case I would have 10 here, we put the minus, and here I would have 2.y, right? 2.y done. Then here we can put, for example, a plus. Let's see how it turns out. I'll just put the minus for now, since I'm not sure if it should be plus or minus. The common factor would be 2b, right? So we're going to put 2b. We open parentheses and say, by what? I multiply negative 2b to get negative 2bx. So that would be by 10. Then, what do I multiply negative 2b by to get plus 4b? Well, first, by negative. 2 times 2 is 4. So here there's a 2, and it has to be 1, right? There it is. Notice that if I multiply this by these two, then I get these two over here, right? Can you check it yourselves? Let's see. Here in the denominator, it turned out fine, because here we already have x minus. And as a common factor, look, here it is. So the denominator is properly factored, but I want you to see that the numerator still isn't. Why is that? No, because here we have a minus 2b, and here we have 2b minus a. Does that mean we have to change the sign here? So, what am I going to do? Look, I'm going to do it right here. Let me change this sign. I'm going to switch from positive to negative. If I make this one negative, I must switch the signs inside here. This becomes negative, and this becomes positive. So now, I have minus 2b, which is the same as what I have here, minus 2b. Okay, was it really necessary for us to do that so it would work out? Anyway, notice that we're not doing anything wrong. Look, if I do minus and then minus 2b, minus times, minus is plus. So here, I would get plus what? 2 by. This gives 2 by which matches here. And combining this and this gives minus times minus, minus, so it becomes minus ay, which matches this one. Therefore, I'm not doing anything wrong. Okay. So now let's continue. Let me see if it still fits over here. I hope we are going to factor then, because this one and this one, well, now they do have a common factor. Therefore, I'm going to write the common factor, which is a minus 2b. I'm going to make the letters a little smaller. Okay, I open parentheses. And in this case, then I'm going to have to write 2x minus y, right? 2x minus y, and that's it. Now I have the entire numerator factored, and in the same way, we're going to factor here. Notice that here we have x minus 2e, and here we also have x minus 2e. So we're going to write that, x minus 2e. I open a parenthesis, then close it. Sorry, I close the parenthesis and open it again. And I write a minus 2b, a minus 2b, and close the parenthesis. And now, look how nice this is. Why? Because we can see that the a minus 2b will cancel out with this a minus 2b, since dividing them gives us 1, right? What do I have left? In the numerator, I only have 2x minus y, and in the denominator, I have x minus 2y, x minus 2y. Done, we're finished. Now we have the simplification of this algebraic fraction. I only included exercise number 7 because I really don't know how much I might need to extend the explanation. Since honestly, it's not going to be as simple as it might seem. It looks pretty simple because it's small, but it's really not that easy. Now, I want you to notice that in this case, here in the numerator, we have a difference of squares, right? So in order to factor it, what you need to do is take the square root of 10 to the 4th, which in this case is 10 squared. Then we're going to add the square root of 16, which in this case is 4. And that's going to be multiplied by this same conjugate term. That is, I'm going to write it, but with a negative sign, like this, okay? So I've already factored there, and now we're going to factor, sorry for interrupting, we're going to factor the denominator now. So, let's see. While I write this on the board, start thinking about how to factor 10 cubed plus 8. How do you factor this? Well, in this case, this is a sum of cubes, right? 8 is a cube, and 10 cubed is a cube. Therefore, we have to use the following formula that says how to factor a sum of cubes. That is, for example, a cubed plus b cubed. What we have to do is write a plus b, and that will be multiplied by a squared minus ab plus b squared. That's how you factor a sum of cubes, right? So, come on. Let's factor the denominator in this case. So at the beginning, we have to write a plus b, which is the cube root of a cubed and b cubed. So in this case, I should write 10 plus the cube root of 8. which in this case is 2, right? Now we open parentheses. We write a squared. In this case, I'm going to write 10 squared. We then write minus ab, which is minus this times this, or minus 2x. Finally, we add b squared, so plus 2 squared, which is 4. There you go. Now we have the factorization. Let me remove the red text since we'll analyze it soon. Let's clear some space. And also, we're not done yet. Why not? Because, as you can see, in this case, we can't cancel anything. Does that mean then that we have one of two options? Either it's set up incorrectly, or we really need to keep factoring. In this case, it's the second one. We need to keep factoring, since this part here can still be factored. Careful here. Why? Well, we know this is a difference of squares again, so we can factor it again. I don't have room here, so I'll use the next line, okay? Let's see. So I'm going to copy the 10 squared plus 4 just as it is, and now we're going to factor the 10 squared minus 4 again. How? By finding the square root of 10 squared, which is 10, then adding the square root of 4, which is 2. We open parentheses and write the square root of 10 squared, which is 10, we put a minus sign, and we write the square root of 4, which is 2. All right, and now, in the denominator, we're going to copy exactly what we already have there. We can't factor it any further, right? So let me copy it. It's x plus 2 times x squared minus 2x plus 4. There you go. Look, now we can finally cancel something, right? Which one? It's this one, right? The x plus 2 with x plus 2. So what's left in the numerator? Well, only x squared plus 4 times x minus 2. And in the denominator, I have x squared minus 2x plus 4. All right. At this point, we have already simplified our algebraic fraction. Notice that it seems strange here. I know. It seems strange that this right here is the simplification of this. At first glance, this seems much more complex than what I have here. But remember that what we really need to observe here is that the degrees of the algebraic expressions we have, both in the numerator and the denominator, have decreased. So in this case, they did decrease, right? Because look, here we have a polynomial. Well, once we expand it, we would have a third-degree polynomial, and here we have a second-degree polynomial. Notice it was fourth and third degree here, so the degrees decreased. Therefore, that means that's how we simplify. Okay, well, let's copy exercise number 8 now, and with that, we're done. All right, here's the last one. I'm going to ask you to do the following. Please pause the video and try to solve it first. I know it's the most complicated one, but it's really important that you challenge yourselves. Try to answer it yourself by pausing the video. Once you have your answer, resume for my explanation. Ready? Did you pause it? Perfect. Now go ahead and tell me, even if it's just in your mind, how did you do it? How did you factor the numerator? Well, in that case, we can factor by grouping, right? So let's go ahead and factor the numerator by grouping. Let's reconsider. What's the common factor between these terms? It's am, right? So we put that am as the common factor. And I ask, by what? I multiply am by a squared to get a cubed m. Next, to get minus 4am, I multiply by minus 4. I'm still not sure here, so I'll add a plus. Now I wonder, what's the common factor between these two terms? Well, it would be n, right? So we put an open parentheses. What do I multiply n by to get a cubed n? Well, it would be by a squared. It's starting to take shape, right? Then here it would be by minus 4, right? By minus 4. In this case, it's properly factored since we have a squared minus 4 in both places. So we're going to have to factor again there. Well, we'll be able to factor there. Sorry, let me put the line. Let's see. Now, in the denominator, as you can see, we can start by factoring out the common factor, right? See that this one has a squared, this one too, and so does this one. So we're going to take a squared as the common factor. And now I ask myself, what's left inside? I multiply a squared so that I get it to the fourth power, so it would be by a squared. Then here it would be by minus 4a, right? So let's write minus 4a, and finally it would be by minus 12. Right? Minus 12. In the case of the numerator, we said that we can still factor a squared minus 4 because it's a common factor. So let's do that. In this case, I would have a squared minus 4. What does it multiply by? Well, here it would be m, and then it would be plus n, right? Ready? We've already factored. We draw the line. We put the a squared that we already had here as a factor. And now we're going to factor. This trinomial is in the form 10 squared plus bx plus c. So let's remember, what we had to do was open and close a pair of parentheses. We placed the square root of a squared, which is a, here and here. And we look for two numbers, such that when multiplied, they give me minus 12, and when added, they give me minus 4, which would be minus 6 and 2, right? So, here we put a minus 6 times a plus 2. Sorry, there it is, right? Minus 6 times plus 2 is minus 1, 2, and minus 6 plus 2 is minus 4. So is it factored, right? Let's see. I want you to notice that here we can still keep factoring some things. Look at the numerator. Here we have a squared minus 4, which is this right here. Well, it's really a difference of squares, so we can factor it. And here we can still factor as well. Also by common factor with a, as you see, let's first factor this difference of squares. So we calculate the square root of a squared, which gives me a. We add the square root of 4, which gives me 2. And we're going to multiply this by its conjugate binomial, that is, by a minus 2. This is the factorization of a squared minus 4, right? So, this product of binomials here, we're going to factor out the common factor a. So here, I would have times a. I close the parenthesis and say, by what do I multiply a to get am? Well, it would be by m plus. By what do I multiply a to get an? Well, it would be by n. All right. Well, I had already told you that the last one was going to be a little complicated, right? All right. I'll draw the line and allow me down here to just express it a little differently. Instead of writing it as a squared, let me write it as a times a. It's still a squared, right? Here we have a minus 6 times a plus 2, and I'll write it just like that, a minus 6 times a plus 2. Now let's see what we can cancel out. I want you to see that the a plus 2 is up here, and also down here, and also the a is up here and down here as well, okay? That's why I wrote a squared as a times a for clarity. We're done now. So, what's left in the numerator? Well, only a minus 2 multiplies m plus n, while in the denominator, I have a times a minus 6. All right. In this case, we can't simplify anything else. So we're done here. We already have the simplification of our algebraic fraction. And well, that's all for today. I hope this video was helpful for you. But most importantly, that you enjoyed it. If you liked it, please subscribe to this channel. See you in the next video. Bye. Thank you.